Okay, we're back up. Let's finish up this section. So the next thing we need to talk about is the scope. And let's just write these out to make sure that we can see the scope. Just hold on, just read those to me.
There exists z parentheses.
That was a z.
What are
That's
you
an X.
reading, Jake?
Okay, I can't read it. Just merge
Made me think my eyes are...
Number 1, Leah.
Okay, mx or rx.
Okay, so we'll look at this to understand the scope of a formula, or the scope of a quantifier. So the scope of a quantifier is the quantifier together with the smallest following formula.
Why is it called the scope?
The scope, it's what its reach applies to.
So its reach applies to this.
So its scope is this.
No.
There exists an x such that mx or rx, this rx over here, this existential quantifier does not apply to that.
Oh, I'm going to do that.
So if you meant it to, you'd have to put parentheses here. Now you're saying this.
For the smallest
Make sense?
Yeah.
following.
So let's do the next one. Can someone read to me? For all y,
There exists x. X is greater than y.
Explain that to me.
oh, sorry. There exists
What is
x.
the scope for the most simplest?
And then x is greater than y.
So it applies to the smallest
parentheses z
formula.
and parentheses z equals 2. Is that it?
Yeah.
And parentheses z equals 2.
And it's not for all y, it's just y. Oh wait,
I have
he does that.
question.
That's how for all y's. So for all y, and he's only signifying the there exists x. So the x quantifier is applying to
Yep.
this.
Whole statement.
Oh, the whole thing.
No,
Yeah.
it
so-
stops
scope
in
of-
between.
scope of it.
Stops in between.
It stops in between the second parenthesis.
No, it
Doesn't.
doesn't.
No, it doesn't.
That's just the tools that author's using. It doesn't make sense because starts here, holds there.
So if you have the variable, say x, and it's outside of the scope of your quantifiers, how do you interpret it?
When it was right here.
Yeah.
So are you saying how do we determine if it's true or false?
Does there exist x like define it or establish a precedent for it?
There exists x such that mx or rx.
If that was an
This
and,
there exists does not apply to the x over here.
if that was an and, would it have to be inclusive?
No.
So
This is a formula, correct?
Yeah.
This formula came after this quantifier?
Yes.
Yeah. Scope. The scope of a quantifier is the quantifier together with the smallest following formula. Keep going until I've reached a formula, then I'm done.
Right.
So mx, that's a formula.
Right.
That's all it applies
So-
to.
Y is the bottom one.
Parentheses,
Parentheses.
right? We're grouping all this together, so now it has to apply to the whole thing.
Okay.
We didn't group this together.
So that's the smallest formula.
Yes.
Okay.
This is the smallest formula following this. Because notice, this is not a formula. Right? And it's not going to be a formula until we get our closing parenthesis. Make sense? I guess we didn't really talk much about the use of parentheses in formulas, but yeah, you can't just have hanging parentheses. Doesn't make sense. And I think that was a side note after he finished this. I think he made a side note at the bottom, and parentheses are used as expected or something like that when talking about formulas. So basically use parentheses as needed. Anyways, so let's look at another one to write out the scope of it.
There exists x, then y.
Oh,
And then parentheses, x, y equals 0, and parentheses, and x, parentheses by itself. And then z
So,
parentheses.
for all x.
For all
and
Yeah.
for all x.
And for all z, such that x plus z equals z plus x.
Jeez. Really
We're running out of space.
I think it's just
Come
trying
on,
to prove
man.
a point.
You ain't black.
Like that, and then one more parenthesis.
Yeah.
Okay, and then this existential quantifier is applying to the whole shebang.
Because you have to include the and.
It's really just like order of
No,
operations.
why doesn't it end on 0 actually?
No, why doesn't it end? Yeah.
Why doesn't it end right here?
That's a formula.
Because there's no.
Because this is not a formula.
There exists x such that for all y such that.
That is not a formula. What are we missing?
The
end
The
of-
closing parenthesis.
Yeah.
Beautiful.
So why are you containing there exists and you didn't contain for all y things?
Well, we are just specifically talking about the scope of this. We could talk about the scope of this, sure. What's the scope of this? The scope of this is this.
Wow.
What's the scope of this? The scope of this is this.
Okay.
Mm.
So yeah, we just happen to be talking about the scope of the there exists x. Right?
I thought it's saying, look at this, find the scope, and the scope is
No.
going to be the smallest term.
The problem isn't to find the scope. We're giving you examples of scopes of
Big formula.
quantifiers.
Do you need to put an
So
and
quantifiers have scopes.
between quantifiers?
Do you need to put a what?
And.
No. This is perfectly valid way to do it. Because, so looking at it with the y, from here on, this is a formula, right? Ignoring the there exists x,
Yeah.
that's a formula. Using this rule, or this rule, all we did was took r, which was a formula, and added a there exists x. Still perfectly valid formula. Right? Okay. Any questions about the scope of a formula? Or the scope of a quantifier? Makes sense?
Yeah.
Yeah? No? Yeah? Both?
You did that wrong, just saying. Just want you to know that.
Which one did I do wrong?
The scope should include there exists x.
Well, James was saying, James was asking what about this quantifier? So I erased it. I did have it like that before.
We did this one.
That's what I started with.
Let's get you in.
So yeah, if we do the there exists x, that one is this. Do the whole thing. Good? Okay, so that's the scope of a quantifier. Now, an occurrence of a variable is bound if and only if it falls within the scope of a quantifier. So, the occurrence of the variable x here is bound. The occurrence of it here is not bound.
Explain yourself. Together with.
The variable x occurs here twice, here and here, right? An occurrence of a variable is bound if and only if it falls within the scope of a quantifier. This only has one quantifier in it, so there exists x. This x falls within the scope of this quantifier. This x does not fall in the scope of a quantifier.
Oh!
This one is bound, this one is not bound.
Okay.
An occurrence of a variable is free if and only if it's not bound.
Right, so
This is a free occurrence of x, this is a bound occurrence of x. Okay?
So on the
Is
very
this x free or bound?
is bounded.
Bound.
Is this y free or bound?
Bounded.
Is this z free or bound?
Bounded.
It's free.
Hello?
It's
Uh-uh.
no, it's within
It falls
the scope
within
of
the
There's
scope.
there's
Okay,
no.
okay,
there's
now I
no-
see what you're getting confused by. It's not the scope of any quantifier, it's a scope of a quantifier about that variable. There's no quantifier about z. Just because it falls within the quantifiers of x and y, it doesn't matter. Z is still free here, x and y are bound.
No. Oh, because there's
Yes.
a y quantifier.
Oh yeah, there's a y out here.
Yeah.
Sorry, I'm covering that. Alright, what about here? Free or bound?
Bound.
Bound.
Bound. Bound.
That doesn't
No,
make sense.
shut
That's
up.
quantifier. That's quantifier.
Bound.
Bound.
Bound. Bound. Bound.
Alright, they're all bound. Wonderful. So those were all bound occurrences. Okay. So we know when an occurrence is free and when an occurrence is bound. Now we're going to talk about a bound variable and a free variable. This applies to the whole formula, not specific occurrences. A bound variable is a variable. A variable is bound, or it's a bound variable, if and only if at least one occurrence of it is bound. And it's a free variable if and only if at least one occurrence of it is free. Is X free here or is it bound?
Both.
It's free and bound. It's both. It has at least one occurrence where it's free, therefore it's a free variable. It has at least one occurrence where it's bound, therefore it's a bound variable. It's possible to be free and bound. It's not possible for an individual occurrence to be free and bound. This was a bound occurrence, this was a free occurrence. But the variable x in this formula is free, and the variable x in this formula is bound.
It's funny. Take a logic class and get taught, yes, things can be free and bound.
It's just like open and close sets. Never mind.
We don't know that one.
Okay. Let's look at this one.
I know what that means.
Is x a free variable?
Yes.
Is x a free variable in this formula?
Yes.
No.
No.
Oh, there exists X. Sorry. I was a little
Is x a bound variable?
Yes.
Is y a free variable?
No.
No.
Is y a bound variable?
Yes.
Is z a free variable?
Yes.
Is z a bound variable?
No.
Alright. What about this?
They're all bound.
They're all bound. There's no free variables. X is free and bound. X and y are both bound. Z is free. They're all bound. Good? Okay. So now we can finally get to the definition of a sentence.
Crazy.
A formula without any free variables. That's what a sentence is. It's a formula without any free variables.
So that's not a sentence. There exists X.
This is not a sentence. This is not a sentence. This is a sentence.
Can you give the definition of a predicate just one more
I'll
time?
put it in words.
Say that
You
again.
erased it. Can you give the definition of a predicate one more time?
Oh, I didn't give a definition because the book didn't. I said the intuition for a predicate is it's a property that a term possesses, or it's a relationship between terms.
Okay.
That's my own internalization of what I got out of the predicate section. I could be way off the mark for some reason that I don't know. I just read the chapter and that was my best way to sum up what a predicate is. Same thing you guys all did before you came here.
Right.
Exactly.
Yeah.
You really
Okay. And now we're ready for the last section, which we're just going to do
Final
Final
example.
example.
one final example that has a lot of words in it, and we're going to.
It's a whole section called the final example.
Because now we're going to do what we're going to be doing from here on out.
Oh, it's 24 steps.
So we aren't dealing with sentences and wait.
We are doing this.
This final example.
English.
The point is, now we're going to be doing what we need to be able to do from chapter 4 on out. We need to be able to take sentences, and we need to be able to identify their terms, predicates, and quantifiers, and put those in. We already got used to doing the sentential connectives. Now we need to be able to do it with terms, predicates, and quantifiers.
Grammar and logic. Understand.
Okay. Someone want to read the sentence to me?
Which one?
Yeah.
The bottom.
If one instant of time is after a second, then there is an instant of time after the second and before the first.
You gotta go slower. If one instant of time is after a second,
Yes.
A second. And there is an instant.
come.
Is the first.
Of time after the second.
If one instant of time is after this.
Then there is an instant of time.
After the second.
And
And before the first.
Of course.
Wait, so is it talking about a second or is it talking about like a second?
Second is in second place.
Okay.
Does not imply that time is infinite.
So,
Right.
one
Two,
instant of time
you have
is
the
after
first-
second.
You have the first time.
Infinitely divisible.
There's an
Ah, yeah.
instant of time after
Okay.
the second.
But it still doesn't imply that time is continuous.
It doesn't?
No. Between
Okay.
any two rational numbers, there exists a rational number.
Right, that's what this is saying.
Yeah, but
So this doesn't give you the real numbers yet. So far, that's just rational numbers.
right.
Got you.
Hmm.
It's basically the Archimedean property.
Yeah.
Oh.
Went over it, James. There's just X in the actual numbers. And then
Okay,
there's that.
so let's go over this. Alright, there's a lot in there. So we got one instant of time, we got another instant of time, and then we got a third instant of time that we're talking
First
about.
instance.
So is it A, B, C, or D?
So, and it's an if, so we know we got an implication going on, right?
Oh, we're diagramming this?
Yeah, we gotta break this up.
Time
So,
right
is
now.
an instant of time,
I thought I was done with that.
is an instant of time we'll use big T for, right?
Little T.
Okay.
So we have, let's just write it out again. If X, if instant of time applies to X,
What's X?
Time.
our first instant of time,
So why do you have a T there?
It's the first,
T is showing the first, right?
or sorry.
T is my instant time predicate.
So it's
So maybe we'll write it this way. T equals is instant of time.
Okay.
So if one instant of time, so if Tx, one instant of time,
Is after, which is
is
another predicate.
after, yep, we're gonna need a predicate for that. Another instant time, Ty, comma, then there exists
Another predicate.
Z such that
Z is.
What is
So you
it?
need before the first.
yeah, we're gonna need, let's
You
use
need
more predicates.
Quantifier your predicates of after the second.
So let's do A4 is after,
Yeah. Yeah. And is before.
and we'll do B equals is before. Let's just again. So if
TX.
Tx
Are we gonna
A
be?
Y.
if Tx
equals AY.
if T is an instant of time
And yeah.
and Y is an instant of time such that after, what comes after? Y comes after
There
X.
exists after
Yeah.
X.
So Y is after X, right?
Mm-hmm.
So if that, then
Then T.
There exists.
Then
Then-
TZ.
there exists Z such that,
Why did you introduce Z that way if you introduced X and Y now? Oh, okay, right.
because it's not the
Yeah,
same,
yeah, that's right. That's right.
there is an instant of time, call it Z.
Such that
So instant of time applies to Z, and let's see, Z
and B Z
after the second, so Z is after the second, after Z, Y,
and B Z A.
and
I mean
before
B, Z, X. The first.
before the first, and
Yeah.
Z is before the first, right? So there's just a rough scratch. This obviously isn't our final thing yet, right?
Yep, next.
So let's do it again. So
And we
we've
have
got
the implication.
Tx and
So you want, yeah.
Ty
Parenthesis.
and no, and after Yx, that implies that there exists Z.
Got your E's backwards.
Oops, thank you. there exists Z such that T applies to Z and after Z, Y, and before ZX. Is that my phone? Okay. Before ZX. Let's see how close we are to what he's got.
I don't think he
Is that the final example?
TX and
That's exactly-
TY
That's it.
and after XY. Oh, X is after Y? If one instant time X is after another, we screwed the order there. X is after Y, right?
So you can be switched up there too.
Then there's just an instant of time after the second. Z is after the second. And Z is before the first. Yeah.
It's after the second.
And
After the second one listed.
Thought you clapped.
Oh.
Right?
No, you dropped your phone.
So question, is this a sentence? If one instant of time is after a second, then there is an instant of
No,
time
it's
after the
not.
second and
It
before the
is,
first.
it is.
hello?
Read this, is this a sentence?
No.
It's not?
Look, are there any free variables?
X
Yes.
and Y.
Well,
That's
just
my
intuitively, is this either true or false?
Yes.
Yeah? So is this a sentence?
Oh. But it has free variables.
My intuition says no.
Right, it has free variables.
My intuition says yes, but
X and
says
Y are
no.
free variables in here. What is going on?
Shut up.
Hmm.
What the fuck?
So,
You
Should
should
see how to finish
what's
it.
the
Do you
difference
have to
between
go?
a
There
statement and a
exists
sentence?
X. There exists Y.
Is that what it's saying? Is it saying that there exist two instances of time such that if
No. It's not saying.
For all instances of time, there exists.
for all X for all Y is what it's saying.
For one instance of time.
For any two instances
There
of
exists.
time such that the first is after the second,
There.
there exists a third instant of time. And now if we do this, we need
Not,
another parenthesis. Like
Why?
this, and like this. Because we
Oh,
want
man.
this to apply all the way through.
Oh, that's weird.
So that's how we would do it. There's that sentence. I think.
I have it. Oh, there it is.
Yep.
Should do what he does with brackets. That's cleaner. See what's going on. So there we go. That's what we're going to be doing from here on out. You're going to be taking sentences like this, and you need to convert them like this real quick so that we can start doing proofs with them.
Real quick.
Yeah. 15 seconds tops. And that is chapter 3. Not too bad. We went through a whole chapter. Yeah.
Oh, that's crazy.
We probably still have a bit more time that we can record, so we want to do some homework problems.
Yeah.
What homework problems we want to do?
Number 5.
The hardest one.
Well, we can go back and do previous homework problems for what we did before. I just didn't want to do those at the start of class because I already had the whiteboard full. So let's start by, do we want to do any problems that you should have done before you showed up here? Were there any of those that you got stuck on?
Ace them all.
You aced them all? Alright, so let's randomly pick one and Jacob will show us how to do it.
Great.
If I
Ace
had
them
them,
when I was in the zone.
then I would have aced them all.
None?
Let's pull out our phone, shall we?
I did have one that I couldn't solve, but I think it might have been an option to not solve it, but I'm not entirely sure.
Okay, let's look at it. What one was it?
So it was the last section of chapter 2, and it was 3B.
Did I pass it?
Yeah, you did. It's on that page.
B. Fusion is not correct.
Wait, how many
So-
classes?
What are we doing? Prove if possible by reductio ad absurdum. Okay. So we're gonna do, this is gonna be just like a proof by contradiction problem,
Right.
right? Okay, so I need the premises, someone wanna read them to me?
If Hinduism is not correct,
I'm pretty sure I said hedonism before.
Yeah.
I honestly that's not correct. I thought you said
Hinduism is not correct, very much.
Hedonism.
It's not if.
Yeah, start with an if.
W.
Someone gonna read it?
Then
If?
Not Hinduism.
eroticism is not virtuous.
I'm not sure how to symbolize that one. Does it give letters?
Yes.
please?
HEDS.
So not E.
So, not virtuous on the E. Okay. Is that the whole thing?
Okay, if eroticism is
You do
virtuous,
that because of
then
life.
either duty is not the highest virtue.
So, hold on.
Not
If,
E implies.
if, which one?
So if E, then D
Then D, I guess.
is not,
It's not D.
Oh,
No, it's not
it is
E.
virtuous.
E implies not D.
or S.
S.
Is that not applying to both of them, or is it like that?
The not only applies to the D.
Yeah.
Okay. That was a premise. 3.
Okay, but S is not, so
So not S.
Not
S.
Virtuous.
Is that it?
then therefore either duty is not the highest virtue or hedonism is not correct.
So D.
Either not
No.
D.
Not D, no.
D
Sorry.
or
Yeah,
not
either
H.
not D or not H.
Either D or not H. Did I hear you right?
No, it's
Not
not
D
D.
Not
or
D.
not H.
Not D or not H. Okay. So that's what we're trying to prove.
Wait, no. D represents.
That's the therefore, dummy.
It represents that duty is.
We're
the
looking
highest
at B,
virtue.
right?
Yeah.
But the supreme duty is not the pursuit of
Okay,
pleasure.
that makes sense.
Supreme
Is that the right one?
So
Yes.
duty is not the highest virtue is D.
It's not.
Supreme duty is
It's not.
not
Yes.
Because it has a.
Where is he
the pursuit of pleasure.
Said during the Greek
Let's read this
Roman
again.
times, it's-
If hedonism is not correct, then eroticism is not virtuous. So if not H, then not E. If eroticism is virtuous,
I thought that's
E,
one.
then either duty is not the higher virtue, not E,
Yeah.
Including 20.
or
Did you make it?
No.
the supreme duty
Class of 2020.
No, just 20.
is pursuit of pleasure.
That, don't you?
So
No,
not,
I do that too.
not
Oh,
D
and that's
or
what he's doing
S.
with S, right?
Yeah, you guys
Yeah.
ready?
Okay,
Over the laptop.
so S is duty is a pursuit of pleasure. The supreme duty is a pursuit of pleasure is S. Okay. But the supreme duty is not the pursuit of pleasure, so that's not S.
There's one thing. I haven't read it.
No. No, you got it wrong.
Yeah, that looks so wrong.
It's therefore either duty is not the highest virtue or hedonism is
Oh.
not correct.
But the supreme duty, oh yeah, that was the last one. Okay,
Yeah.
oops. So, what was it?
Not D. or
Not
not
D.
H.
Therefore, either duty is not the highest virtue, not
I
D,
heard you like a real person.
or
Not
hedonism is not correct. Oh, that was right.
Yeah.
Yeah.
Oh, sorry. Okay,
That's cool.
and it said to do proof by contradiction,
Yeah.
and you were wondering if it was even possible. So remember, how do we check if an argument is valid?
You see if the premises are
Prove it right.
consistent.
You see if
See if
it's
it leads to
if there's a
false.
possible interpretation where the premises are true and the conclusion is false.
Right.
Okay? So let's think about that for a second. So we need S to equal false, so that not S is true,
Mhm.
right? Let's see. If S is false and
That would mean D has
That
to
would
be
mean
true.
true, be true.
only if we
D
want
has
this
to
to be true, we could also just have E be false.
Oh, okay.
So we have two possibilities. We can have, it looks like either way we can go E true or E false and we'll be fine. But remember that we want this over here to be false with D's true. So if I want these to be false, I want to make D true. And I want to make H true, right?
Yeah.
Because then this over here is for sure false. So let's see if we can still make these work. So false implies anything, and we're fine, so we can make E whatever we want to make this true. Let's see, we wanted D to be true,
And you want
so not D is false. False or false is false, so we need E to be false. And now we need H to be false. Right?
Mhm.
So let's
You
write out
already
our
said that.
premises now.
You
So we
just-
have false implies, or sorry, we have true implies true.
You have a contradiction there, I think. You have
You want
H is
H
true,
is true,
and H
H
is false.
Oh, oops. Thank you. Right, now we already used H. So let's go back. So
You
we
want-
have,
You want H to
You want
be
H to
true,
be
so
true,
that
so
not
that-
H is false.
Yeah.
we have to have this. We have to have D true and H true.
And you
right?
have to have S false.
And we have to have S false. So what's the last one that we're missing?
E.
We're missing E.
And E is false.
E, how,
Let's see, H is true, so this is false. So we can make E whatever we want.
No, it has to be false.
E has to be false because this is false, right? So let's rewrite this. If H is false, or if H is true, then this is false. So our first premise is false implies true, right?
Right.
Which is true, we're good. Our second one is false implies
false, but true.
true and false is false. So we're good there. And our third one is just true. And our conclusion is false.
And that's not an and though, that's
Wait,
an or.
no.
True or false.
You're saying this one?
Oh, false or false.
False or false is false. So our conclusion
False and false is
is
true.
false or false.
false
So false or
implies
false is false. So we have true premise, true premise, true premise, false conclusion.
Yep.
So since there is an interpretation,
So you can't solve.
So this is possible. So we have to find a way now to do it, but it is possible.
no.
No, it's
It's
not
not
possible.
possible, that's what you just proved.
To do the
false.
problem.
He's saying
It's
all the
possible to do
premises
the
were
problem.
true, but the conclusion was false.
We came up with
That means it's not possible.
an interpretation.
Doing the problem is possible.
No,
No.
that's what we just really showed is impossible.
It's impossible to solve the problem.
The argument is not valid, is what we showed. It is not possible to come to that conclusion with just those premises.
Okay. Oh, okay.
Make sense?
Yeah.
So yeah, that's that.
But the problem is possible. It's like, you can do
The
the problem.
conclusion is the argument is not valid, so you can't construct
You
an argument.
can't construct an argument, but it says prove if possible. By
Right, it's not possible to prove that.
I know I'm saying.
I don't know what we're saying. I think we're saying the same
The
thing.
question that originally came up was is it even possible to do this problem? And we just did it. We answered the question.
We answered the question. It's not possible to
It's not
do the
possible.
proof.
Yeah, that's the answer.
Yes.
The answer is
It's an
don't do
invalid
problem.
argument. Yes. Invalid argument. Okay, so that's that. Any other questions on homework problems? Okay, looking at new homework problems. See if there's any that catch your eye.
New? Is that what you said?
Yeah, so for what we just did today. So the first problems come down and start after quantifiers, I think. Okay.
Wow, that's like a screen map level.
State without the use of variables the following two true statements of arithmetic. Oh geez, it means write that out in words.
Let's not do that.
Yeah, I'm not gonna write that out in words. You guys can do that.
Rip.
Yeah, you
No
have to
phrase.
think of some cookies.
Huh?
It's the law. Or it's just-
I'll just write exactly what it's saying, but.
So
So for all x.
translate the following sentences from everyday language into notation using terms, predicates, quantifiers. Let's do some of those. All right. So Leah, pick one of those.
Pick number
Do
two.
Elizabeth.
Pick
No,
number
Martin,
eight.
Come on,
freshman.
Leah. You're up. I can't stand anymore. I'm broken. Catch.
Wait, what are we actually doing?
The one you
You're
picked.
taking a sentence and you're representing it in terms of, you're representing it with quantifiers, predicates, and variables.
All seniors are.
Sure. Yep, just pick one and do it.
Sounds about right.
Write out what the actual sentence is first, and then
You're not senior anymore.
let's see. It says all seniors are dignified. Am I reading that right?
Yes.
So all seniors are
So
dignified.
you want me to write out?
Yep, write that sentence up there. Just like we keep track
It's
of
gonna
it.
be for every senior.
Wait.
Jacob, you can do the next one. Pick yours.
Some juniors are pretty. I like that one.
No. Freshmen are big.
All right.
Did you just say juniors?
Some juniors are pretty.
That's what it says.
Levi? Oh, you're
So
senior.
for
I'm senior
all,
now.
Yeah, and then Leo is
All
junior.
X.
How do you do it?
You don't have to use their predicates if you don't want. You can just make up your own letters.
All seniors are dignified.
Is that a senior? I hope so.
There exists.
For every person.
well, dignified is are dignified is that predicate?
And
Is
Isn't
a senior.
seniors a predicate?
you're gonna have
Isn't
two
seniors a
predicates.
property that people have? And they're a senior?
Is it seniors a term?
Nope. X is
For
a-
every
It's
X,
a variable.
if X is a senior, then
Such that
yes.
as X
Yeah. You're gonna have an
implies-
implication.
No.
What do you know? You know if someone's a what, then they're what.
as
No.
SX and DX.
Senior implies that you're a dignified.
Oh, no.
Right,
Yeah.
if you're a senior,
That's
then you're
it.
dignified.
Yeah.
And your parentheses, boom, there we go. And that's a sentence, right? No three variables.
Jake's going up and about to rip a new one.
Alright, who's going after Jake?
Me.
Okay,
Ooh. Oh, you got it.
Wait, I thought me and
write your sentence.
No.
Ah, you're on camera, people need to know what you're doing.
When you expect to be a teacher, God.
Some juniors are pretty.
Okay, coming
Or
from
you
you.
would think that.
Not
one
for
X.
all.
For all X.
There exists
Okay.
X.
1 second. Okay, tell me if I'm wrong here, but you go
Wow.
J of X and P.
First off, you just crossed your A again.
Oh, there exists. Holy cow, yeah. Okay, one second. Let me for all X. 1 second. Maybe I just do this.
Maybe. Ah, it's looking better. Don't cross the N.
Ooh.
Missing a couple
Yeah,
parentheses.
you are.
Put your parentheses around there exists X.
No.
No, that was mine.
Why?
There you go.
Why?
There exists X such that X is a junior and X is pretty. Some juniors are pretty.
You hear that, Leah? There's hope.
Thanks, Jake.
Alright,
How about the boys?
next sentence.
Still thanks.
Who's going after Evan?
No.
There's hope.
Alright. Get your sentence ready to go. No freshmen are dignified. Poor freshmen.
Cheating.
Can I say that? All freshmen. No.
There
All X.
No.
All X. There exists freshmen who are not. I swear root. Who are not dignified.
You have to do there
Let me
exists.
see it.
You need to do there exists though.
Oh, no we don't.
For all
That's
freshmen.
perfect.
Yeah,
Alright,
that's
all
special.
such that. Right,
For
right.
every person, if they're a freshman,
Then
then
they're
they're not dignified.
Nice.
Works perfect. Alright, who's next?
I need to choose a sentence.
You did pretty
You were
well.
supposed to get that ready.
I know, I think I got it.
Slider.
I want to choose one that
Who's
is
going after Levi?
too hard and isn't too easy, you know what I'm saying?
Em is after Levi, pick your sentence.
Which one of these is good?
Whichever one you're holding.
I did
There are some
before you.
seniors who like Greek, but not.
I don't know the last.
Alright, write your sentence.
Okay.
Some freshmen are not.
That's not too much fun writing this book.
He did it first.
Oh,
Save
the
it.
person who wrote that down when you had a lot of fun writing it.
The person you want to do speak math or cut off and writing.
Some seniors are both dignified and
Oh, he chose a harder one.
And you want out, choose.
pretty.
Yes.
Alright.
Did it quick.
Who's going after Levi?
I am.
Emma. Oh yeah, we already figured that out.
And the stone.
There exists a person such that they're a senior and dignified and pretty. Perfect.
Variables.
There exists someone who's a senior, dignified, and pretty.
Could you,
Oh, that's a parenthesis. I thought that was.
Donnie, if you wanted to, could you make dignified and pretty just one predicate?
Sure.
You just gotta clarify it, don't you?
I do DP and then that's on.
They're small enough, I just do it how we did it. Go ahead. Who's after Emma?
I don't know.
Peter?
Decimal over here.
That's
Math putting on. Great, I can beat the world.
it's a
He's got his oversized one.
dude. Oversized boat now.
Like those pants being baggy and draggy.
Oh yeah.
You wear those too.
Every freshman dates
No, it's preferred.
This is
Some-
gonna be a harder one.
junior.
That's nice.
Yeah,
I can't do as good as anything.
That's gonna be a little more tricky.
So, I'm gonna
For all freshmen.
For all X.
Where X is a freshman.
Freshman.
Wait, don't you wanna
X
say there
being a
exists,
freshman
Dates.
and
there exists Y, right?
Yeah.
Don't you have to add that, quantifier?
Would
No,
it
you
be
don't.
implies?
It could be X, they can both be X.
Every freshman.
no.
Oh,
I think
it's,
that would make like every
Because
freshman
X
date
is just
some
a
junior.
person.
Or,
can you put two
Oh.
predicates side by each other?
yeah, I'm sorry.
So can you put DJ
Alright, no. That's
X?
You would just split
you
it.
put DJX.
Oh yeah, just split them with the name. Dates, junior, person.
There exists
All
Y.
freshmen.
Nice.
Dates.
No.
Such
Junior.
There
Is
exists.
Such that Y.
You could say JY
Yeah, such that J.
or whatever.
Perfect.
Wait.
For
That's
all
all
X,
it
X
is.
being a freshman implies there exists Y. Oh, you didn't specify
Now
what Y is.
Y is a senior. Y is a junior.
Right.
Right.
I would
Or
do that.
Y is a junior and X dates Y. Perfect. And I think you need one more parenthesis. Yep. That makes sense to everyone?
Yep.
For all X, X being a freshman implies there exists a Y where Y is a junior and X dates Y.
These guys here have to go in
That's sweet.
Yeah, that's great. Alright, Pete.
Pet Pete. Pet
That's
Pete.
with Pete.
Pet Pete 4 in the house.
Oh yeah.
Who's after Peter?
The one and only.
Me.
Robert 888.
James.
It's Dark Mummy 26.
Pick your sentence, James.
Oh, I picked it. And
Okay.
nobody picked it.
Bad. Boy, Cody. Didn't know what the signs are.
Not all juniors
Picture. No idea.
Still nice.
are pretty. That's for sure.
Not all juniors. The opposite of Jake.
Okay?
No, the opposite of Alan actually.
I said
Not
some.
all juniors are pretty.
Saying not all juniors are pretty and some juniors
yeah.
are pretty.
Mm.
Is that the same thing?
Slightly different in the things
For
that business.
all
exists.
people.
I guess
Yes,
not.
Juniors.
I guess some could be there,
Implies.
all of them.
Oh, wait.
X
If I have
being a
some marbles,
junior
do I have all the marbles?
There exists
You
some
could.
juniors who are not.
Right, that's
implies
So they're not saying the same thing.
not
No.
pretty.
Right.
That
on
means
X.
all juniors.
Is that right?
Not that.
That means all
That means
juniors,
all juniors
are
aren't pretty. There
Oh.
are-
Juniors
there
are
some
not pretty.
juniors who are not pretty.
So just
So there
change the not
exists.
to this to the front instead of right there.
So right here.
Not all.
So right here.
Clear at the start.
Here at the start.
Now, how do you distribute that through? If you remember how to do that.
I
To exist,
It goes there exists something.
there exists X.
So the rule was, if
There
you have something
exists
at the point
some
of this,
juniors who
if you have not for all X, some statement about X, that was the same thing as there exists X such that not S of X.
Right.
so you
Right.
need
Oh,
there
so-
exists some
yeah.
juniors who are not
This is the
Right,
same
right.
Right, that's
You can just do it
so
like
it's
under it.
it's
Yeah.
just saying there's a junior that's not pretty.
Yeah.
That's what it's gonna
So
say.
you all have to not is the.
There exists X.
We're
So
taking
How the
that
heck
as
are you
fun.
gonna not that thing?
How the heck am I what?
Gonna not that thing? An implication. Crazy. See what you got.
Which is
No.
Wait.
right.
Okay.
Right, that's right.
Yeah.
That means they're not a junior.
Seems okay so far.
Uh,
There exists someone who's not a junior. Yep, that's true.
And someone who's a junior is not pretty.
yeah. Play something.
There exists someone who's a junior and
And
not
junior.
pretty.
Oh yeah. And
Wait.
No, no,
Hold on, finish your thought and then we'll
I
correct.
said not. 3 times.
No, there is
I
someone.
realized what I was saying.
There is a person
You're like,
who
not.
is not pretty, right?
There you go.
There we go.
Oh yeah.
So that's one way you could have done it. The other way you could have done it is, remember, A implies B is the same thing as
A.
not A or B.
Mm-hmm.
So this and this are the same. And now you need to not this. When you distribute your nots,
Oh,
you switch your ors to your in, so that then becomes
this.
JX and not PX. Yeah.
Or you remember what
So
James
you
was.
did distribute the not through, which just kept thinking about it instead of actually going through the operations. But yeah, good. All right, James, you're up.
Man in the house. Moment of the
Ugh.
moment of the second in time.
Is the camera still going? Yep. Probably gonna have like 13 minutes left, so don't take too long, James.
It's gonna take forever and it's just gonna be on spelling.
Just keep going, stay talking. Elizabeth
Which one?
does not date
Cute.
freshman.
Very fun.
Any.
That's fine, we got it. Okay. Elizabeth does not date any freshmen.
Does not date any
Okay.
freshman. Okay.
James is diagramming his
Yeah.
Parenthesis or
For all
X,
such that
EX, right?
No.
for all people,
X,
She doesn't date any freshman.
that is a freshman.
capital R's for predicates.
No freshman does she
No
date.
freshman. No.
That's my
Yeah,
capital
well,
F.
For all X.
That's how you do
such that
capital
X
F?
is Elizabeth.
Wow. Okay,
No, actually.
for all people,
Oh.
X for all X, X being a
All right.
freshman,
Elizabeth's not your freshman.
Very good.
If they're freshmen.
implies if you know they're a freshman, what do you know about it?
You know they're freshmen, then what do you know about Elizabeth?
She doesn't
You don't say it that way.
doesn't date-
If you know X is a freshman, what do you know about X?
They don't date Elizabeth.
So X doesn't date Elizabeth.
Yes.
Right back.
X doesn't date
So not EX.
Not date Elizabeth. X.
No.
Not.
You can't just throw in.
Yeah,
Not
that's what I
date.
see.
What's wrong with that?
I'm throwing
That's a free variable.
What's a free variable?
E.
No, it's not. E is a constant. It's Elizabeth.
Oh.
Yeah.
There you go. That's
Oh,
it.
That's
yeah.
perfect.
That's it.
Oh yeah.
Yeah, there you go.
Dex.
Elizabeth.
Not Dex.
For all X, if X is a freshman, Elizabeth does not date X.
Your F looks like fur, dude.
Don't write a capital F. This is
Yeah.
how I write my capital F.
How do you write a lowercase f?
Yeah, you see that curve? And it's bigger?
How do you write capital E?
I go like this.
Okay. Yeah, that's good. All right. Oh, we didn't line up someone after James.
That's
Donnie.
Is that everyone?
Yeah.
That's it.
All right. Need to do more problems, or should we call it good?
Unless there's a harder problem.
We can call
I think
it
that was
that.
pretty good.
I think you guys got a pretty good feel for it now, right?
Yeah.
Yes.
So let's look at what this one is, number 1 here. Classify the following as terms, formulas, or neither. All right, perfect. Let's go through this.
Okay.
Terms, formula, or neither. Okay, Thomas Jefferson.
Term.
Slowly.
Neither.
Neither.
The number 6.
Neither.
Term.
Term.
Yeah.
Okay.
Isn't that a formula?
Okay. No.
No.
Oh, okay. Then we'll just call it a term. X is purple.
Formula.
The integer X.
Why?
Term.
Right, but
Term or formula?
It's a term.
Term.
That's a formula.
Oh, because it's
The integer is a predicate.
yeah.
Just like instant of time in our other one. The number X such that X equals X plus X. Formula. Isn't that just talking about one number?
It is talking about one number. Ah.
Yeah, that's a formula. And there's an equals in there, for goodness sakes.
Hey.
X plus Y equals X or Z?
Z.
Z.
Formula.
Formula.
That one.
X plus Y plus Z squared.
Formula.
No.
Term.
Where?
There's no relationship in there. There's no predicate in there. There's no
Oh,
predicate.
got me.
Just a bunch of variables.
Just a number.
Every man X.
Formula.
Term.
That's
It's
like
a
getting it.
free variable, isn't it? So it's not.
Feels like neither.
Yeah, that one's awkward. Is that neither?
It has a predicate
Neither.
in it.
Every man.
Yeah, but it's not exactly a formula.
So for all X such that
X is a man.
and X.
That's a formula.
Got him.
Right? Because that's just going to be this. For all X, man X.
Yeah.
Because this is a formula, and you can add a quantifier on it. It's a formula. So, yeah, I think that works.
That man who will be the next president. Joe Biden.
That man who will be the next president.
Like a stat.
Isn't that
What
just
is that?
Term.
That's just a term. It's a description, right?
Oh.
One and only one person will be the next president. X hates Y but loves Z.
That's a formula.
That's a formula.
And there's formula right there.
3 plus 1 plus 10.
Term.
Term. Very pretty.
Term.
Neither.
Neither. Very pretty isn't an object.
Very
Did you
pretty
see very
axe.
pretty over there?
Very pretty Jake.
Now you're using it as a predicate.
Yep.
You hear what we said about you, Jake? Be concerned.
Hey.
Okay, I think we can call it there. You guys can go home and do